Hey guys, welcome back to another episode of the SMA Victor Podcast. In today's episode, we have a fascinating topic to talk about, which is the next treatment medical breakthrough for SMA patients. We are about to soon dive in. I am currently wearing these glasses because if you have been watching my previous episodes, you will know that I have a backlight, and this backlight has been significantly blinding as I look towards you guys, and the backlight's like right behind. And when I switched from here to looking at my screen, going back and forth, my eyes were adjusting, and it was a mess to say the least. So I found these glasses that are primarily meant for computer usage, and I finally got them today. So I've been testing them out, and I am totally loving it. It totally works. I think honestly, I'm totally going to use them during the summertime, even though summer passed already. I'm totally going to use it. All right, let's get right into it. Hi, ChatGPT. I want you to be my co-host within today's episode. And within today's episode, we are going to be discussing CRISPR for SMA, the next breakthrough in treatments.
That sounds like an exciting episode. I'm all in as your co-host. CRISPR for SMA is definitely a game changer, and we can dive into how it works, the potential benefits, and what it means for the future of treatment. Let's do it.
Yeah, so let's get right into it. I apologize too in advance if my head is doing this a lot within the episode. My neck is feeling fatigue. It is currently 8:30 at night as well, so it's been a long day. But let's get right into today's topic. CRISPR gene editing technology is a promising area of preclinical research for spinal muscular atrophy, SMA, with ongoing laboratory studies and recent breakthroughs in related fields. However, it is not yet an approved or currently used clinical treatment for SMA in humans. So, ChatGPT, for the audience at home listening, myself included, what does this mean?
Absolutely. So basically, CRISPR is a tool that can edit genes with a lot of precision. When it comes to SMA, the idea is that CRISPR could potentially correct the genetic mutations that cause the disease. The fact that it's still in the preclinical phase means it's not yet tested on people, but the research is super promising. So in a nutshell, it's an exciting possibility for the future, but we're not quite there yet.
I think it's fascinating. I came across CRISPR and I was like, we have to make a video talking about it. Excuse me. We talked briefly about it within my animated Monday videos in previous episodes, but I wanted to do a full dive research talking about specifically CRISPR for SMA. I heard it's making a lot of groundbreaking medical breakthroughs for the SMA community. So I wanted to look into it to educate myself and also make a video to educate, spreading awareness on it as well. Preclinical research. Researchers are actively investigating CRISPR-based strategies in lab models. One promising approach involves using a customized CRISPR-based editor in activates the A comparable gene, SMN2, to produce normal levels of the necessary SMN protein, potentially overcoming some limitations of current therapies. Another strategy involves combining gene supplementation with CRISPR to enhance durability and effectiveness. So what does this mean?
So in simpler terms, the idea is that SMA is caused by a deficiency in a particular protein. And CRISPR could help boost the production of a similar protein from a different gene called SMN2. This approach could potentially bypass some of the limitations of existing treatments. And then the other strategy is to combine CRISPR with gene supplementation, which could make the effects last longer and be more effective. So it's a really innovative way to tackle the root cause of SMA.
So gene supplementation, are you meaning replacing a faulty gene with this CRISPR medication/treatment?
In a way, yes. Gene supplementation typically involves providing a functional copy of the gene that's missing or not working properly. CRISPR can help by editing the genes at a very precise level, and in combination with gene supplementation, it can essentially restore the normal function of that gene. So it's like a two-pronged approach to really fix the underlying genetic issue.
That's actually really huge because, okay, so we have SMN1 protein and SMN2 protein. Now, SMN1 and 2 are similar but different and complex. So SMN1 protein, sends signals to communicate from our brain with our bodies. And SMN2 gene does the same things, but slightly different, but the connection is significantly reduced. ChatGPT, did I explain that correctly?
Yes, you explained it really well. SMN1 and SMN2 are indeed similar genes, but SMN1 is the primary source of the protein that our body needs for proper muscle function. SMN2 is a bit of a backup, but it produces much less of the functional protein, and it's not as effective. So your explanation was spot on.
Okay, so let's move on to the next one. No active clinical trials for SMA. As of late 2025, there are no active human clinical trials specifically using CRISPR to treat SMA. The field is still in the experimental and development phase for this particular disease. Then it follows up with saying challenges. The main challenges include ensuring the safety and precision of in vivo gene editing to avoid off-target effects, and developing effective delivery methods like AAV vectors or lipid nanoparticles to target motor neurons and other affected tissues effectively. So what does this mean?
So this means that while the research is really promising, and not yet at the stage where CRISPR is being tested on people with SMA, there's still a lot of hurdles to overcome. One of the big concerns is making sure that the CRISPR edits are super precise and don't accidentally affect other parts of the genome, which could cause unintended side effects. Also, getting the CRISPR tools to the right cells in the body, like the motor neurons that are affected in SMA, is another challenge. So it's still in the experimental phase, but the progress is definitely exciting.
Has there been any recent data talking about the potential release for this kind of clinical trial?
As of now, there aren't any confirmed dates for when clinical trials using CRISPR for SMA might begin, but the research is definitely moving forward, and we can expect updates in the near future. So it's an exciting time for the field.
Wow. That alone, though, should make you optimistic. That's keeping me optimistic. It's in the process, it's in the works, although it's not promising and guaranteed. Just the thought of them making that significant type of breakthrough within the SMA community, to me, is astonishing. Let's move on to the next topic, distinguishing CRISPR from current SMA treatments. It is important to differentiate CRISPR from the currently approved, highly effective SMA treatments. Zolgensma, a one-time gene replacement therapy that delivers a healthy copy of the SMN1 gene via a viral vector, approved for children under 2 years old. Spinraza and Evrysdi, small molecule or antisense, ASO, which is abbreviation, therapies that modify the SMN2 genes splicing to increase the amount of functional SMN protein produced. These are ongoing treatments, not one-time genetic cures in the same way a successful gene edit might be. So what does this mean?
So in a nutshell, the current treatments for SMA, like Zolgensma, Spinraza, and Evrysdi, work in different ways. Zolgensma is a one-time treatment that basically delivers a healthy copy of the SMN1 gene to the body, but it's mainly for young children. Spinraza and Evrysdi are ongoing treatments that you have to take regularly, and they help increase the amount of the SMN protein by tweaking the SMN2 gene. Now, CRISPR aims to be a more permanent solution by directly editing the genes, which could potentially be a sort of long-term fix. So it's like moving from a treatment that you have to keep up with to a potential cure. It's definitely an exciting distinction.
That's huge. By ChatGPT explaining where, how Zolgensma is primarily for infants. And I have a full video talking about Spinraza, Zolgensma, and Evrysdi as well. Spinraza was firstly released, then it was Zolgensma, and then third it was Evrysdi. And Zolgensma is for infancy, Spinraza is for young adults, and Evrysdi is for the same amount of people. Obviously, every SMA patient cannot entirely be guaranteed to be a candidate, for we all have our own unique SMA. I don't want to say every single one of us with SMA is unique, to put it simply. And if you want to learn more about specifically these types of three medications, Spinraza, Zolgensma, and Evrysdi, you can look at the history of this YouTube channel by going to Q&A or learn more about SMA playlist, and you will find these videos as well. Let's move on to the next one. Oh, but where I was going with that is huge because Spinraza, like for example, I take Spinraza. I've been taking Spinraza since 2017. And Spinraza is amazing because it modifies the SMN gene, where it helps to say like, hey, there's a signal here, let's try to get going. But CRISPR sounds like it's going to talk about, not just be like an assist, but more of a solution. Now that is really, really huge if you really sit and think about that. That's significant. I didn't know that. I'm so happy I began this podcast. The next one, it says, the next breakthrough potential. While not a current treatment, ongoing research, especially in light of the first ever FDA approval of a CRISPR-based therapy in late 2023, is accelerating the development of gene editing treatments for other conditions. Recent breakthroughs in personalized CRISPR therapies for rare metabolic disorders in a first-in-human trial in 2025 further demonstrate the rapid progress in the field. CRISPR holds promise as a potential next breakthrough for a definitive, potentially lifelong genetic cure for SMA by directly and permanently correcting the underlying genetic defect. But this is still several years away from clinical use. Okay, so now we have an idea of when we can expect this. I think that is significant, extraordinary within the SMA community. And I am curious, I wonder if the more awareness we bring to the SMA community, I wonder if funding can help further advance the process of this phase. I wonder if we can further the advancements of research with this phase. I wonder if funding would make any beneficial benefits during this phase, during that process. I'm actually very curious. ChatGPT, what does that mean?
That's a fantastic insight. Essentially, the progress in CRISPR technology is really picking up speed, especially after the first ever FDA approval of a CRISPR-based therapy. And this means that the field is moving faster than ever, and it opens up the possibility of using CRISPR for conditions like SMA in the future. And you're absolutely right. More awareness and funding can definitely help accelerate this research. The more support these projects get, the sooner we might see some of these breakthroughs become reality. It's definitely an exciting time.
ChatGPT, I think this was a great episode. I learned a lot from today's episode. I hope you guys did as well. ChatGPT, I want you to summarize everything within today's episode, and I want you to provide key takeaways for the audience, for myself and the audience as well, where just in case you skipped throughout the video, I want you to understand everything that happened within this video. But if you would like to see more, I highly recommend you either watch the video again or go back where you skipped. ChatGPT, please go ahead.
Absolutely. Here's a quick summary of today's episode. We dove into the exciting potential of CRISPR for treating spinal muscular atrophy, or SMA. While CRISPR is still in the experimental stage and not yet in clinical trials for SMA, The advancements in CRISPR technology are very promising. We talked about how CRISPR differs from current SMA treatments. Existing treatments like Zolgensma, Spinraza, and Evrysdi are effective but require ongoing administration or are limited to certain age groups. In contrast, CRISPR holds the potential for a more permanent solution by directly correcting the genetic defect causing SMA. We also touched on the fact that although it's not ready for clinical use, the overall momentum in the field is encouraging, especially with the first FDA approval of the current for Bay therapy in late 2023. This means that the future for CRISPR and SMA treatment looks bright, even if it's still a few years away. And of course, the more awareness and funding we can generate, the faster we can move toward making this a reality. Hopefully that sums it all up nicely. And if anyone wants to dive deeper, they can always revisit the episode.
I think this was a fascinating episode. By far, probably one of my favorite episodes, if not my favorite episode, since I began making videos for the SMA Victor podcast. This was a great episode. Please let me know if you personally enjoyed. If you got any value from this episode, please like the video to help me within the algorithm, to help the channel within the algorithm, because again, the more people that know about SMA, the more awareness we bring to the SMA community. My intention is to grow an audience within this channel to spread SMA awareness, where we can help further more medical treatment breakthroughs, again, for the SMA community. It would be extraordinary to be part of such a significant impact, and we can do that together. Please comment down below what it is you learned from this video, what it is you discovered within this video. Have you heard of CRISPR treatment? Have you heard of it? Have you not? I recently came across it, and I immediately had to make a video talking about it. And subscribe if you are new. I am so close to 100 subscribers within this YouTube channel. At the time of this recording, it is currently November 3rd, 2025, and I am so close to 100 subscribers. I currently have 84 amazing, incredible, remarkable subscribers within the SMA community. All thanks to you guys. You guys are amazing. I love you guys. I appreciate you guys. And as always, remember, grow through what you go through. Much love.